hello everyone. Um, Good morning. I'm very happy here to talking about this topic with you today. I decided to talk a little bit about building performance evaluation. And first of all, let me talk about a little bit of my background. I am a civil engineer and I graduated here in Brazil. And I also have a master degree in BIM from England. And right now, I am a BIM modeler at AEC Brazil, which is also one of the sponsors for this event. And part of my experience in construction area was during handover and post-occupancy. So it's a very interesting stage in the construction process because everything's becoming really tangible. And part of my job was dealing with snags and construction defects. That's why I really like talking about building performance. It's a very important topic. Because after all, we're developing all this technology, all this innovation, and this is awesome, but the reason is, of course, to deliver better buildings, more efficient and more economic buildings. So when we're developing all this technology, we need to keep this on mind all the time, how we can deliver better buildings, how we can improve in performance. And I find sometimes that is a very neglected subject. That's why I decided to bring this topic today. So let's start talking a little bit about building performance. In a very few words, is basically the qualities of a building that we can predict, we can control, and we can measure. And buildings are a very interesting product. I can call it as a product because each one is unique and it's a complex of systems and subsystems and elements, and we have a plenty of variables affecting the performance. And we can measure in many aspects, and I like to divide them in three macro ones, which are comfort, sustainability, and economic. And these three aspects, they are all connected to each other. So for example, if a user is not comfortable inside a building, he'll probably change the temperature settings, lighting levels, and this will affect how much the building will consume energy and also how much is gonna cost at the end of the month. So also measuring the performance of the building can be done in many ways, and it's really hard to develop a common framework with all the metrics and how to measure it. But it's hard, but it's not impossible. That's why we have so many third-party assessments doing a validation for higher performing sustainable buildings. And we have BREEAM, that is quite popular in UK. We have LEED, popular in US. Well, that is a new one, relatively new one, third-party assessment, and passive house as well. We had a presentation where it was the lady talk about passive house, and if you miss it, I really recommend to you to see it later. It's really interesting. It was really helpful. And out of these third-party assessments, they are really trying to measure the sustainable aspects of the building. They have a very holistic approach. So they will be measuring many aspects of the building. So the comfort of the user, the health and well-being and their behavior, many sustainable aspects as related to energy, waste production, water use, and other economic is a very important aspect of the building. They don't actually measure directly the costs of the operation, but as everything's related, they have indirectly measuring by how much you consuming energy. You can also measure how much you'll be costing. So we have a performance gap. That is basically when the building is performing below what we want. And this is a topic that's mainly discussed regarding the sustainable aspect, how much the building will impact on the environment. And why? This is because buildings are accountable for 1/3 of the energy consumption, and around 77% is just for heating and cooling, and the remaining part is for other uses like lighting and appliances in general. And the biggest issue is how much higher the energy consumption, higher is going to be the CO2 emissions. This is because 86% of the energy the buildings are using are from non-renewable energy sources. So we need to make efforts to improve these numbers. Besides that, we also have many studies pointing out that buildings are consuming energy 1.8 to times higher than the initial prediction. So this is why we need so much effort to make these changes, because we need to build more efficient buildings to reduce the impact on the environment. And why this gap happens, we have so many reasons, and just the causes we could be talking about the whole day. So I resume them in these ones that I find the most important ones. So the first one, new buildings are awarded based on design intent, not on real performance. Most of the third-party assessments, they are measuring the design intents, the design solutions, although BRIA and other have different categories for the assessments, like new buildings, refurbishment, in use. The majority of the time, the building is getting their certification on the new ones. That's what they want to bring, want to show to the society. Some people might argue there are a lack of strict regulations, so we should improve that. Wrong to analysis. This is regarding not only the limitations of the softwares itself that are modeling, the maths behind it, but also using the wrong software. Each stage of the construction demands a different tool, because as we progress in the construction process, we're getting more information about the building, so we need to be aware of that. Lack of details and specifications, so change orders, poor handover process, and it's all related to a fragmented industry. So working in silos, we cannot have a good communication. Construction defects that I talked about at the beginning. So every time you do something wrong and you need to correct, we are causing damages that we cannot measure. No post-occupancy evaluation, that is the topic I'm talking today, the importance to measure building performance, because when we don't do that, we have inaccurate usage predictions. We cannot identify how much the building is going to perform based on not understanding how people are using it. So basically, all these causes are related with poor communications and how designers and contractors and other people involved in the construction process get feedback about their work and their solutions. So, well, not everything is bad, so we have issues and we need to talk about as well the solution. And I put this chart that I find very interesting. It's an idea how we can reduce our contributions to CO2 on the environment. And you can see that technology is playing a huge role on that. So we have to improve the way we work so we can change that. So BIM is a very new way to construct as we are improving communication and also using more technology across the construction chain. And then we need to evaluate the building. Evaluating is basically a systematic approach where we can measure the performance and confront them with well-defined criteria. This is not new. This is very common. This is a very topic. It's plan, do, check, and act. If you're not checking, we cannot act. We cannot improve what we are doing. And we cannot only just measure. We need to measure and analyze, and we need to confront them with a minimal performance requirement, targets, and goals. And I find very interesting because this is quite common in any other industry, but for construction, we have this issue. So for example, we have smartphones and they are continuously collecting data to improve their products, but it feels like in the construction area, we just miss that. So gathering real metrics is really important to create a benchmark database where we can use this info to input in performance simulations. So I put here 2 examples from Sapphire and Autodesk Insight. They are both simulation tools for early stages of the construction process. And even in this moment where you don't have much information about the building, you are already putting loads of occupancy density, occupancy profile. If you're putting the wrong numbers, you're gonna get results that will be not accurate. That's why it's so important to have an idea how the buildings are working now. So when we're doing this analysis, we can define solutions that will actually be effective. And I really like this Chart's workflow. It defines a very well ideal process for construction from the building life cycle. So even from starts from the design stage, we need to have performance specifications, and as these processes are developing, we need to measure the real performance, and then we can validate them by identifying the difference, and then we can create data that can be used to driven actions for us. Well, but we do evaluate buildings in a certain way, and this graphic shows the usually methods to measure performance, and they usually divide into single types, subjective methods and the physical measurements. And usually they are conducted in a very traditional way, using interviews, questionnaires, direct observation, or even mechanical recording. And the issue with that is why people are not evaluating building is because it's time demanding and to collect and analyze this data. And also there's like a not common sense who should be responsible to perform. Should be the designers, the owners, the operators. So no one knows. And it's also difficult to engage occupiers in the process of providing feedback. And all this way to collect data, it's seen as only a static evaluation. So after you deliver the building, 1 year later, you go back, measure a little bit with your questionnaire, and maybe UK soft landing propose like you doing this for 3 years. But building can last for years and years, so you need to have a continuous appraisal of the building. So that's why I really like to bring about smart buildings, because, well, that's the future. And I put this example here, which is a building from India. It's a smart building There was a project for Intel, and they have more than 9,000 sensors. And this is his building management system architecture. As you can see, they have so many sensors collecting many metrics regarding lighting, energy consumption, cooling and heating. Even they have smartphones as is an office. They have a smart application where the user can download and control the building, like temperature settings, lighting levels. So instead of we doing one single evaluation of the building once in a while, this should be shift from to an ongoing measurement, what I like to call real-time building monitoring. And most important, not only collect this data, but also provide feedback for the design to the designers and contractors about what they build. Yes, and that is some very interesting aspects, because all these metrics, the sensors I'm measuring are the same metrics that we are measuring, that I showed for you on the beginning of the presentation from the third part assessments. Well, and I want to talk at the end finally about the challenges. Why we have so many options to improve the way we evaluate building, but what are the challenges? Why we're not doing this? Because basically challenges are problems not yet solved, so I can call it opportunities. But why collecting all this information is really hard to use on and to to use them back on the models. First of all, because data collected for the sensors are unstructured, and it's really hard to analyze them without making some adjustments, some changes. Second, the amount of data, of course. If you're measuring continuously the performance of the building, you're gonna have so many data, and you also need to ensure consistency and long-term archiving of this information. And data is also not instantly fed up in the models. This is not automated process, so it's still necessary a lot of human input, and this is time demanding as well. So we need to find ways to automate and collecting this data and returning back to the designers and contractors. Heterogeneous data, each part of the construction, they use different type of data, and sometimes it's hard to align that. Interoperability of the data between the systems. Getting the right data is also really important. Not all data that you're collecting from buildings are useful for you. And also one very important is, like I showed from this building from India, where they have 9,000 sensors. That means that you have 9,000 more assets to maintain. And this is difficult. It's like you need to know which one is not working, where they are located. This is gonna be really hard. And also technology is evolving really fast, and we need to make sure that they're not gonna become obsolete in a few years, as every year softwares are releasing new versions, and we need to keep them working. The cost, of course, not only for the capital, but also to operate this, like to maintain. Maintenance is also cost a lot. And finally, data privacy and security. This is also a very important aspect on smart buildings, because the users might not feel comfortable being monitored all the time. So if you have an application for the users where they can connect to the buildings and change. Some people might not feel comfortable. They will just not use it because they feel like they're being observed all the time. And if people are not using what you design, so it's useless. So this is a very important aspect. So this is a very interesting topic, and this is like the very much opportunities for us to change the way we evaluate buildings. So that's what I had to talk to you today, and I am very pleased to hear from you. If you want to talk about what you've been doing or what you wanna change about it, yes, that's it.